2.3, solving systems of equations, or at least systems of equations. This is the good stuff. Here we go. We're talking about system of equations, or a system of equations. So what does that mean? So let's go ahead and define it. So when it says a system of equation right there, we're talking about just two or more equations. They could be linear, they could be anything, but we're just going to stick with linear equation. So if you have two or more lines, you have a system of equations. So there's three main types that we're going to deal with. So we've got the standard one where there is one solution, and that is where you have a line, then you have another line, and where they cross is your solution. That's the thing that you're solving for. There is a no solution, and that is where if you have two parallel lines, so they're never going to cross, so there is no solutions. And then you have, let's say if you've got your line here, and then your second line is the exact same line. So there you have an infinite number of solutions. So that's just two equations that's describing the same line. So these are our three cases. Obviously, this one is going to be the most common, but if you don't find an answer, if your answer is weird, then it's either going to be a no solution or an infinite number of solutions. So let's try to solve some. So the first way we're going to try to solve these things is just by graphically. We start here because hopefully it gives you a concept or an idea of what is actually happening. So easy enough. Let's just graph these two equations and we'll be good to go. So this first one right here, already in y equals mx plus b, or y-intercept form. So our y-intercept is -6. So we're going to go find, we're going to zoom in. Our -6, we'll put a little dot there. And then our slope is, we'll say, up 1 and to the left 3. Because if I go, I'm not going to be able to go down 5. So 1, 2, 3, 4, 5. 1, 2, 3. Put a dot there. And then again, I'm just going to put a couple dots just for fun. 1, 2, 3, 4, 5. 1, 2, 3. So then we can just draw our line like that. Okay, so our next line, we'll even use a different color for it, maybe. Our y-intercept is 5. Then our slope, up 1 over 6. So I'm actually going to go down 1 to the left 6 because that's the direction I want to go. So down 1 and over 6. 1, 2, 3, 4, 5, 6. That's convenient. Down 1, 1, 2, 3, 4, 5, 6. We'll put a dot there just for funsies. So our solution is going to be that guy right there, which is -6. Where's that? 4? Yeah, -6, 4. So it is a point. We put it in parentheses, circle it, because that's our answer. Number 3, slightly more challenging because it's not the equation's not in an easy form, but that's okay. We'll figure it out anyway. So I'm going to change these equations into y equals mx because that's how we graph them, right? So this first one, I'm just going to automatically move the x over. So I'm going to have -5 y equals -45 minus 6x And then we're going to divide everything by -5. And I'm going to move the x over to where I want it. So y equals a positive 6 divided by 5x and a positive 9, because 45 divided by 5 is 9. So there's our first equation. So 9 is our y-intercept. Put a dot there. We'll just do the negative of both of our slope. So that's going to be down 6. 1, 2, 3, 4, 5, 6 over 5. 1, 2, 3, 4, 5. There's our line. And then our next line, again, I'm going to move this over there automatically. So we got 2y equals -2x minus 4. Divide both sides by 2. Got -x minus 2. A little bit easier. So that's our y-intercept. -2, put a dot there. And then this is the same as -1 over 1. So we'll go up 1 and to the left 1, because that's up in the positive direction and then left to the negative direction. So that's just going to go. That is definitely not a straight line, but there is our answer, and that's all we really needed anyway. So whatever, it's fine. It's fine. -5, 3. That's the point. That's where they intersect. That's our answer. So the rest of these, I think you can try yourself, and we'll see how it goes. Okay, so we solved those equations earlier using graphing. That's kind of conceptually what we're doing, but there's got to be a more precise way to do it, right? So that's what we're going to do. It's called using math. So there's a variety of different ways we can do it. We're going to start off by learning about how to solve by substitution. To me, this is the most obvious way to do it. It's not always the easiest, but it's the most obvious. So what you're going to do is you're going to first, you'll get, 2 equations. You will solve one of them so that you have an isolated variable. So either x equals blah, 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 or y equals blah, blah, blah. You just want to isolate them. So then you will take that isolated variable and you'll shove it into the other equation. So then you solve, and then you put your answer back into either one of the original ones of the original equations. Whichever one's easier usually is what we do. So let's see what that looks like. So we'll start with our number 7. You'll notice that there's 2 isolated variables already. So we've got y equals some stuff. We've got y equals some other stuff. So we can just pick one. I usually always go with the simplest one. That's this one. So this says y equals some stuff. So we can just take this stuff and plug it in for y into that equation. And that's all it is. So what that looks like, we take this, plug it into there. So then we're going to have x minus 9 equals -7x minus 1. So then we just solve for x. So I'm going to move that over there, and I'll move the 9 over to the right. So then we're going to have plus 7x on both sides. So we'll have 8x over here, and then plus 9 to both sides. 9 minus 1 is 8. Had a brain freeze there. So divide both sides by 8. We have x equals 1. How nice. So now we have our x value, but now we need our y value. So then you just take that x and you plug it into either one of those equations. It doesn't matter which one. Again, I would pick the simplest one because to make our lives easier. So this one looks pretty simple to me, so we'll do that. So we've got y equals, we're going to plug x in, 1 minus 9 y equals -8. So our answer, you're not done yet. Our answer is 1, -8. Remember, this represents a point. So this is our answer. So make sure you finish the problems. What happens when one of the equations is not pre-solved for us? We just got to solve it ourselves. Not a huge deal. So we're looking at these two equations. So when you're trying to do like substitution, you want one of the variables isolated. So usually I would look for the variable that doesn't have a coefficient. That's your coefficient. Because that's going to be a little bit easier to solve for. So this one, if we solve for y, it's just going to be y equals 22 minus 7x. So then we're just going to plug that into our first equation. And we're going to get, it's going to get a little hairy, but it's not too bad. So we got 6x minus 5, and then we've got our y function. So I just plug that in for y equals -28. Okay, so we have to distribute that. So no problem. So we've got 6x minus, 5 times 22 is 110. And then plus 5 times 7 is 35 equals -28. So then we can combine our x's. So 35 plus 6 is 41. And then if we add 110 to both sides, we're going to have 41 equals 82. Divide both sides by 41, we get x equals 2. Yeah. Sounds right. Okay, so that's one of our answers. Now we got to pick one of them to plug it back into. Again, actually, this one right here seems like the best idea, in my opinion, because it's just going to give us the answer. So if we do that one, we've got y equals 22 minus 7 times 2. So y equals, 22 minus 14, which equals 8. Right? Sure, why not? So then, we're not done yet. Our answer is going to be a point where they intersect. That's our answer. Okay, I'll do one more example for y'all, and here we go. So here I am on number 11. Again, we're trying to isolate a variable. So that one doesn't have a coefficient, so we'll use that guy. So let's see here. We'll subtract 3x from both sides. So then we've got -y equals 5 minus 3x. Multiply both sides by -1. We get y equals, I'm going to switch these around, positive 3x minus 5. Okay, so now we plug that into there. So then we're going to have 2 times 3x minus 5 equals 6x plus 10. So we'll distribute our 2. So we got 6x minus 10 equals 6x plus 10. Okay, so we subtract 6x from both sides. That seems weird. So now we have -10 equals 10. So I'm not going to lie. If you get this answer, or something similar to this answer, you should probably check your work. So as I go back through, though, I didn't do anything wrong, but that is not equal. Negative 10 does not equal 10. So this is one of those special cases where there are no solutions. So what I would bet is that if we graph both of these lines, they're going to have the same slope and they're going to be parallel lines. So there are no solutions.